Good afternoon. We will start our class today on confidence interval for the rest. Let's see what we had last time from last Thursday. Last Thursday, I mentioned that we have 4 types of confidence interval to discuss. Let me copy paste that. And last Thursday, we covered the first one, which was not in our book. That was confidence interval for mu with sigma known. So today we will cover the rest. Let me put it here. We'll cover the rest. Make it smaller. Oops. Okay, so today we will do the second part, confidence interval for mu with sigma known, that's 9.2. And then after that, confidence interval for P, that's 9.1. And in the last hour, we'll cover confidence interval for sigma squared, which is 9.3. Now, the template from last Thursday, that was, let me see again. I want to copy paste only. Yeah, the template was like this. That was the template. Right, the first part, the first step, best point estimate. The second step, critical value. The second step is margin of error. And then the last step, we have declaration, and then the confidence interval. So let me copy that template again. So the first step, we have best point estimate. The best point estimate for mu is X bar. The best point estimate for population mean is sample mean. Critical value, that will be the C-score, okay, where the area in the middle such that the right end of that, the area in the middle is the confidence level, okay, and this is the critical value. Step 2, margin of error is the critical value times sigma over square root of n. The third step, declaration confidence interval for mu is given by best point estimate, in this case, X bar minus margin of error less than mu less than best point estimate X bar plus margin of error E. Okay, now the thing is, what if we have confidence interval for mu, but the sigma is unknown? Then we will have most of them the same except for 1b. The critical value, instead of using Z critical, we will use T critical. That's a T distribution that looks like normal distribution. Okay, the shape is very similar to normal distribution. And instead of Z score, standard normal distribution, we use T score. Okay, such that the area in the middle is the same to confidence level. Okay, now that T critical, if we use calculator, it will be inverse T and then confidence level. No, I don't want to use confidence level. That's basically area to the left. That's the confidence level plus the yellow part, one tail, right? Okay, so you will see that's the yellow plus the blue. Comma, degree of freedom. Now, the degree of freedom is always the sample size minus 1, at least in this class. Okay, we'll get into more details for that. We'll get into more detail for that. Oops, that's way too small if we see it this way. Okay, now what other things will change? Then the second step, the margin of error will be, originally we have z-score. Now we change that to the t-critical times sample standard deviation. So if the sigma is unknown, if the population standard deviation is unknown, we will use sample standard deviation instead, in place of population standard deviation, divided by square root of the sample size. Okay, those are the only thing change. So again, it depends on how much you are actually good with the template that I taught you last Thursday, I keep on saying last Thursday, last Wednesday. Okay, it depends on how good you are with the template that we learned last Wednesday. Okay, but once you are good with that, you master that part, then confidence interval for mu with sigma unknown is just a variation of what we learned at that time. Okay, now let's start with some problem from our textbook. I will pick question number, I will do number 19. I'll pick question number 19. Give me a second. I will screenshot that for you. Question number 19. So let's see what we have. A simple random sample of size n is drawn. The sample mean is 18.4 and sample standard deviation 4.5. Part A, construct a 95% confidence interval for mu if the sample size n is 35. So step 1, best point estimate is x bar equals to 18.4. How about the critical value? That will be t critical. Once you use sample standard deviation in place of population standard deviation, then you will use t distribution instead of standard normal z distribution. That's always the case in statistics. Okay, so if we want to find what is the critical value here, then let's see, the area in the middle is 95%, the remaining 2.5%, the remaining 5% will be shared by 2 tails, such that the area of each tail is 2.5%. Okay, so you see that the area to the left of that critical value will be the tail, one tail, plus the 95% confidence level. Right, the area to the left will be 97.5%, right? Okay, so the calculator notation will be inverse t, area to the left 0.975, comma, degree of freedom. Degree of freedom, n equals to 25 for part A, right? So the degree of freedom will be 24, one less than that. Okay, degree of freedom is always, in this course, the sample size minus 1. Now then you will use your calculator. Let me show you how to use your calculator. Inverse t is right below inverse norm. Inverse t is right below inverse norm. So you go to inverse t, right below inverse norm. Then it will guide you with the area first. Remember this area, just like inverse norm, this area here refers to the area to the left. That's 0.975. And degree of freedom is 24. 2.06390. 2.06390. That's the critical value. Then step 2, margin of error E will be the critical value times the sample standard deviation over square root of sample size 25. Okay, so this guy times 4.5 divided by square root of 25, which is 5. I get 1.85751. 1.85751. Now then, step 3, 95% confidence interval for mu will be best point estimate, that is 18.4 minus margin of error less than mu less than best point estimate plus margin of error. Okay, then this is very similar to what we have done before. I get this is 16.54249 less than mu less than 18.4 plus 1.8 something, that will be 20.25751. That is the confidence interval, 95% confidence interval for mu. That's for part A. Part B. Construct a 95% confidence interval for mu if now the sample size is 50. So later on, the degree of freedom will be 49, right? That's 50 minus 1. Okay. We'll construct this confidence interval first, and then we will answer the follow-up question, how does increasing sample size affect the margin of error? You see that if you increase the sample size, then the formula in the margin of error will be, instead of divided by square root of 25, you will divide by a larger sample size, right? Okay, divided by square root of 50 instead later on. Okay, of course, you will see later on that the T critical will change because even the critical value depends on the sample size, right? 1 minus the sample size depends on the degree of freedom. But then you will see that the margin of error, you will divide by square root of a larger number. So we expect the margin of error later on becomes smaller. Okay, the margin of error will become smaller. Now let's put it in practice. Do it from the beginning again. Step 1. Best point estimate. X bar equals to 18.4. Critical value, T critical. The same degree confidence level, right? It will be inverse T. The area to the left is 0.975, the same with the top one. But the degree of freedom right now is not 24. Right now, the degree of freedom is 49. Okay, let's see again how to do that. It's inverse T, not inverse norm. The area to the left, oops, I'm sorry. This is not correct. This is not correct. I punched it wrong. Quit. This is inverse norm, inverse T. The area to the left is 0.975. Degree of freedom is 49. So I get 2.00958. 2.00958. 2.00958. That's the critical value. Second, how about the margin of error? Margin of error E will be the critical value times the sample standard deviation, 4.5, over square root of sample size 50. Okay, so I go back to my calculator, multiply that by the sample standard deviation, divided by square root of the sample size 50. That's 1.27889. Margin of error is 1.27889. Then step 3, declaration first, 95% confidence interval for mu will be best point estimate 18.4 minus margin of error. And then the upper bound will be best point estimate plus margin of error. So you see that the larger the sample size, the smaller the margin of error. Just like what we believed before, that the larger the sample size, the error will get smaller. Okay, the larger the sample we have, the more accurate our prediction or our estimate. Okay, so then I will compute that 18.4 minus 1.27889. That will give me 17 something. And when we have best point estimate plus margin of error, we will get 19 something. And as we expect, because the margin of error gets smaller, then the width of the confidence interval will also get smaller. Okay, so how does the sample size affect the margin of error? That's the follow-up question, right? So if sample size increases, then the margin of error will decrease. Okay, and of course, consequently, then the width of the confidence interval will get smaller also. Okay, now let me ask you to try part C. Let me ask you to try part C. That one is part A. This is part B. And this is part C. Part C has the sample size is 35. confidence level 99%. Let me write down the information again, that the sample mean is 18.4 with sample standard deviation 4.5. Now, can you construct the confidence interval for this case? Okay, so step 1, best point estimate. I want you to do this. Step 2, critical value, that is in T critical. Step 3, margin of error is the critical value times sample standard deviation over square root of sample size. Step 4, declaration, in this case 99%. Confidence interval for mu, that is best point estimate minus margin of error less than mu less than best point estimate plus margin of error. Okay, now let me ask you to do this one. It should take you approximately 5 minutes from now. So right now it's 4:23. Let me give you until 4:29. Please try this. Okay, let me continue. So the best point estimate is X bar equals to 18.4. T critical will be, confidence level is 99%. So the remaining 1% will be shared by 2 tails, 0.5%. T critical is here. So the area to the left of that critical value will be 0.5% plus 99%, that's 99.5%. So T critical will be inverse T. The area to the left, 0.995. Degree of freedom will be 1 less than the sample size. So 35 minus 1, that's 34. Then we use our calculator. That's inverse T 0.995. That's the area to the left, while degree of freedom is 34. 2.72839. 2.72. What's that? 72. 2.7283904. That's the critical value, such that the margin of error will be the critical value times the sample standard deviation 4.5 over square root of the sample size 35. Okay, going back to our calculator, multiplied by the sample standard deviation divided by the square root of sample size. That gives us 2.07532. 2.07532. Did I quote that correctly? Yeah, that's right. So then confidence interval for mu, always declare that first. Always do the declaration. Always. Okay, now that is the best point estimate minus margin of error less than mu less than best point estimate plus margin of error. And we use our calculator to compute that. 18.4 minus 2.07532. that is 16.32468 less than mu less than, if best point estimate plus margin of error, that will give us 20.47532. So you see from these examples here that different confidence level and different sample size will give us different confidence interval. Now, all of these confidence interval will be centered at best point estimate, just the way we did confidence interval for mu when sigma is known, where the confidence interval is basically best point estimate x bar plus and minus margin of error. So the lower bound will be best point estimate minus margin of error. Then the upper bound will be best point estimate plus margin of error. Okay, we will have some exercise later on. If we are given margin of error, confidence interval, can we find the best point estimate and margin of error? Basically going backward. Okay, basically going backward. But we'll do that later on. Let's see part D. What happens if the sample size is 15? What condition must be satisfied to compute the confidence interval? Now, they don't ask us to compute the confidence interval, even though we can. But how about when n equals to 15? What condition must be satisfied? And the answer is the following. Our model actually depends on central limit theorem. Our model or procedure depends on central limit theorem. Okay, so this procedure applies not only for this 9.2, but also for the model we have before. If the sigma is unknown, what is that? Central limit theorem is the theorem that says that if the underlying distribution is normal with the mean mu and variance sigma squared, then the sampling distribution of the sample mean of size n will also be normally distributed with mean the same mean and variance the same variance divided by sample size. In other words, the sampling distribution already normal for any size of the sample size if the underlying distribution is normal, which was not the case of what we have here. There is nothing in the passage saying that the underlying distribution is normal. Okay. Now, so under what situation that we can use this model, this procedure, what is necessary when the sample size is less than 30? Then we need to say that the underlying population needs to be normal. The distribution, the underlying distribution X needs to be normal. But what happened, Thomas, with part ABC? what happened with part ABC? Why in part D only you require the underlying distribution to be normal? Well, that's because for part ABC, even though we do not assume that the underlying distribution to be normal, however, the sample size is already more than 30. Okay, approximately 30. Except part A. No, even part A. Oh shoot, I make a big mistake here. I read it wrong. It should be 35, not 25. Should be 35, not 25. Let me fix this. Okay, let me fix that. So this n should be 35. So the degree of freedom will be 34. Okay, I need to change this though. A lot changed. I need to change this to 34. So this will change also later on. This will change later on. This will change. This will change. This will change. Oh, good thing I see that again. Okay, so this is 34. When I use my calculator, that's inverse T. The area to the left, 0.975. Degree of freedom, 34. Then inverse T will be 2.03224. 2.03224. Okay, now then this will be 2.03224. Now multiply that by sample standard deviation divided by the square root of sample size 35. 1.54580. 1.54580. That's 35. Square root of 35 here. 1.54580. 1.54580. So 18.4 minus 1.54580 will be 16.85420. If you have best point estimate plus the margin of error instead, we will get 19.94580. Okay, so that explains why in part A, B, C, we do not need the underlying distribution to be normal because the sample size is already more than 30. Okay, sample size is already more than 30. That's for part A, B, C. Is it right? For part A, B, C, the sample size already at least 30. So we do not need the underlying distribution to be normal, even though that will be great. Now for part D, because the sample size is not at least 30, then we require the underlying distribution to be approximately normal. Okay, so to answer part D, what condition must be satisfied? And the answer, we say the underlying distribution needs to be normal. That's because our procedure depends on central limit theorem. Okay, for us to be able to estimate the mu using the sample mean, then we need the underlying distribution to be normal or the sample size to be at least 30. Okay. Now, again, if you actually study from what we did last Wednesday, you see that this is actually very similar to what we had last Wednesday. This is what we had last Wednesday. Okay. Now what happens if the sigma is known? Then we will use standard normal distribution for the critical value. Okay, and this is the formula for margin of error. If the sigma is unknown, then the critical value will become t distribution instead of standard normal distribution. But the formula for margin of error, basically the same pattern. You use the critical value multiplied by sample standard deviation in place of population standard deviation. That's basically the only change. Okay. Now, how do we confirm this using calculator? How do we confirm our result using calculator? Now remember that this is to supplement if you want to check if your work is correct or not. Okay, but not to substitute. What I teach you. Now the procedure will be, you go to stat, and then go to calculate, and then go to test, and then t interval. Now, once you get to t interval, you will put in the stats. You choose the input to be stats, and then you plug in the, let me see. So we go to stats, go to tests, and then scroll down to t interval. That's below z interval. You choose the input to be stats. Then what is the sample mean, sample standard deviation, sample size, and confidence level. Let's pick question part A, where the sample mean is 18.4, sample standard deviation 4.5, sample size 35. Okay, and confidence level is 95%. Is it right? 95%? Let me check. For part A. Yeah, 95%. Right? Okay, and then calculate. Let's screenshot that so that we can put it next to each other and confirm. But again, this is not to substitute. I will not accept this answer only in your test. I don't even give any point, not even any point, because the proper way to show confidence interval work is to show in these 3 steps, 1, 2, 3. You're supposed to even write that 1, 2, 3. Okay, so what is the reason our calculator have this feature, Thomas? That's for, especially for some students in high school who needs to take AP statistics, and they have multiple choice, right? So if you want to do it super fast, just to see if you are close enough, this is how you do it, right? But this is in no way what you will do if you need to file a report on confidence interval in statistic community. Okay, even when you do report in future, even if you are in social science or in administration of justice, you apply statistics, there's no way people will accept your confidence interval by using the result from calculator. No, nobody will. Okay, nobody will. Now you see, one thing I know right away, if you just use calculator, you don't show any work, and then all of a sudden you just come up with this interval. No work but that interval. I will scratch it off right away because, and I know that you use a calculator because what? Your accuracy is different from mine. Do you see that? You have only three decimal places, right? While your answer in my test, in my class, should be 5 decimal places. So I know it right away. If you don't show any work, yet all of a sudden you come up with an interval with only 3 decimal places. And I know you just use calculator. Okay. No, it's not that I'm against you using calculator. That's one thing that you confirm if you get the answer right. That's how you use calculator. It's another thing that you need to show your work properly. And I train you as if you need to rewrite the report in statistical sense. Okay, Thomas, I will never take another statistic class anymore. Well, too bad, you take my class. Okay, so I want it this way. If you want to forget the procedure after this, it's up to you, but pass the class first. Okay, oh, my previous teacher didn't teach me this way. Well, maybe your previous teacher never really apply statistic. Right, that person just learned statistic to teach, but never really applying that. You know, okay, no, don't compare me to other teacher because you don't want me to really compare that teacher with me. Okay, there's no need to compare teacher. Okay, now let's do part B. Let's confirm using our calculator. Okay, if you have your TI-84, please do together with me. You go to Stat, and then Test, and then because we use T as our critical value, right? So we will use T interval. The input will be statistics. Sample mean 18.4. Sample standard deviations 4.5. Sample size 50 for part B. And confidence level still 95%. Let me put it maybe here. Let me put it here. So you see that we are accurate to the calculator is accurate to 3 decimal places. We are accurate to 5 decimal places. They are only up to 3. We are up to 5 decimal places. Okay, so we can use that to confirm our answer. Okay, we can use that to confirm our answer. Now let's do some problem from our textbook, the one from the easier side. Maybe I write it this way. How do we find X bar and E, the sample mean and margin of error, if we are given the confidence interval, a confidence interval. So you know that a confidence interval for mu will be X bar minus E less than mu less than X bar plus E. Right? Let's say, for example, we have confidence interval that is 120 less than mu less than 150. Now this 120 represent the lower bound and 150 represent the upper bound. right? Let's write them out first. So best point estimate minus margin of error is 120. Best point estimate plus margin of error is 150. Now, then from algebra 1, we learn solving system of equation by addition method. If I add this, I will get 2 times sample mean equals to 275. I'm sorry, 270. So divided by 2, x bar will be 135. So imagine this. This is 120, 150. Then the midpoint, right? That's basically the midpoint, will be 135. So you see, in general, the formula will be best point estimate is equals to lower bound plus upper bound of that confidence interval divided by 2. Now, how about the margin of error? Well, the margin of error is basically the upper bound minus the x bar, right? In this case is margin of error is upper bound minus the best point estimate. But you can also use the best point estimate minus the lower bound. It will give you the same thing. In fact, you can also use the upper bound minus lower bound. You see, upper bound minus lower bound, the difference between upper bound to lower bound, that's twice the margin of error. You have a margin of error here, you have another margin of error here. Okay, so upper bound minus lower bound give you twice margin of error. To get just margin of error, you can divide by 2. Okay, 150, that's the upper bound minus the lower bound, 120 divided by 2, that's 30 over 2, that's 15. So you can use either one. You can use either one. Now, this is actually on the easy side though. This is actually on the easy side. Let me give you some problem from our textbook. Let's say number 14 and number 16, you try it. Number 14, number 16. I'll put it here. Use the example that I gave you earlier. Try to do number 14. So lower bound is 20. Upper bound is 30. Find the best point estimate x bar. Okay, and the margin of error E. Do that for number 14 and for number 16. Now, after this, then we will go back to confidence interval, a more complicated situation. Okay, find the best point estimate, which is x bar, and the margin of error E. Okay, that should take you like around 3 minutes. 3 minutes, 4 minutes at most. And then we take a little break, 10 minutes break. We will come back at 5:10. Yeah, so 5:10, you are done with these two questions, number 14 and 16. Okay. Okay, let me start working on this. X bar is lower bound plus upper bound divided by 2. That's 50 over 2. That's 25. And you can see that this 25 is really the midpoint of the lower and upper bound, right? With margin of error is the upper bound minus the midpoint. So the margin of error is 5. Number 16, lower bound plus upper bound divided by 2. That's 50 divided by 2. That's 25. Margin of error will be the upper bound minus the midpoint. Margin of error is 10. Okay, now let's go back to constructing confidence interval. But this time, instead of they telling us the sample mean and sample standard deviation, they give us the actual data. Okay, let's say, for example, we take a look on number 31. Let's take a look on number 31. Okay, we have 12 data point here. We have 12 data point here. These are the numbers. And they tell us that this data is coming from a population. This data set comes from a population that is normally distributed. Now then, can we use this raw data to find the sample mean, which is the question for part A? Determine a point estimate for the population mean. That's basically the X bar, right? Okay, but for us to do that, we need to compute a couple things first. Okay, the N, the sample size is 12. We need to find the sum of X and the sum of X squared. Okay, because after finding the sample mean, we need to find sample standard deviation. Okay, now let's compute this using our calculator. Okay, we have 4.58. I will find the sum of X. 4.58 plus 5.19 plus 5.05. Hold on, I want to share this with you. Plus 4.80 plus 4.77 plus 4.77. That's for the first row, 6 numbers from the first row, plus 5.72. Make sure you're careful here though, not to plug in anything wrong. 4.75 plus 5.02 plus 4.74 plus 4.76 plus 4.56. That's 58.71. So the sum of X is 58.71. There's actually another way to compute the sample mean and sample standard deviation using TI-84. I will show you that later on. But for now, let's just do this part this way, slow way. Now, the second thing I need to compute is the sum of X squared. Basically, you square each data and then you add them. 4.58, that's the first data, square. Plus the second data, 5.19 square. Plus 5.05 square. Plus 4.80 square. Plus 4.77 square. Am I recording this? Yes, plus 4.77 square plus 5.72 square plus 4.75 square plus 5.02 squared plus 4.74 squared plus 4.76 squared plus 4.56 squared. That's 288.3609. 288.3609. Is that the number I get? Now, then from here, we can find part A, the best point estimate, which is the sample mean, is 58.71 over 12. That is 4.8925. Okay, but on the side, we still need to compute the sample standard deviation though. Okay, let's do the sample variance first. I hope you remember the formula. That's the sample size times the sum of x squared Remember, that's the first times the last minus the middle square. The second or the third day of class. Okay, I hope you remember that one. So that's the first times the third number minus the second number squared. Divided by, oops, not that one. Divided by sample size times 1 less than sample size. N times n minus 1. Okay, so sample variance will be, let's compute those, 12 times 288.3609 minus 58.71 squared. All of them divided by 12 times 11. I get 0.10202. So sample standard deviation will be the square root of that. That's 0.319406. Now, only then we can use this to construct the confidence interval. We need both of them. We need the sample mean and sample standard deviation from the data set. Okay, now, so for part B, that will be part B, construct and interpret. We'll just construct the 95% confidence interval for mu. Best point as step 1, best point estimate. X bar is 4.8925. And then critical value, that's a T critical. Confidence level is 95%. So the area in the middle is 95%. The remaining 5% will be shared by two tail, each of them 2.5%, such that the critical value has area to the left, 97.5%. So the calculator notation for T critical will be inverse T, 0.975, degree of freedom 11, not 12. 12 is the sample size. Degree of freedom is always 1 less than that. Okay, so now I do the inverse T, the area to the left, 0.975, that's already good. Degree of freedom is 11. So 2.20099. That's 2.20095, right? 995 decimal places. So Step 2, what is the margin of error? The margin of error will be critical value times the sample standard deviation 0.31941 over square root of 12. Okay, times 0.31941 divided by square root of 12. That's 0.20294. 0.20294. Therefore, our 95% confidence interval for mu will be 4.8925 minus margin of error 20294 less than mu less than best point estimate plus 0.20294. Okay, that's 4.8925 minus 0.20294. That is 4.68929. 4.689 what? 26. Less than mu, less than the same entry, but I add instead 5.09514. 5.09514. So the routine is very similar to what we did before. The routine is very similar to what we did before. Okay, once we have the sample mean and sample standard deviation together with confidence level, we can construct the confidence interval. Now, the following will be using calculator. Using calculator to find the sum of x, the sum of x squared, x bar, and sample standard deviation S. Okay, there are some parts. The first part is to clear list. Let me show you what I mean by clearly. We will eventually plug in data into our calculator. Okay, now let me show you the list I have here first. I already entered some data. So to go to your list, hold on. You go to stats and then edit, then you will see the list. Here from my Friday class last week, I taught them how to use calculator already. So I occupied list 1, that's the first column, and list 2 in the second column. Now the thing is how to clear this so that we can start anew. To clear list, we go to stat and then choose clear list, stat, edit, clear list. Now then you choose which column you want to clear. Earlier you saw that you want to clear column 1 and column 2, list 1. That's the second of 1 and list 2, right? So you go to second list 1, comma, second list 2. You will clear list 1 and list 2. See, if you check, it's clear already. Okay, so to clear list, what you need to punch, you go to stat and then edit. Usually that's already in the first, you're already in the edit mode, and then clear list. Okay, then you clear list the clear list that you want, like second, L1, comma, L2. You need to still use second L2 though. And then you enter. Okay, that's to clear list. Second, to input value or to input data. You go to Stat, Edit, and then Edit. Let me show you. So basically you go to Stat. It's already on the Edit, and the first option is already Edit also, right? Now then make sure you key in the correct column. Like for example, what I'm about to do right now is I will input the data into list number 1. Okay, I will input the data into list number 1. Let me do so first. So the first data set data point is 4.58. So you see here on the last row of that screen, L1 represent the list you are working on. Parenthesis 1 tells you that you are inputting the first data from this list. Enter. Now we are now inputting the second data of list 1, which is 5.19. Now, inputting data into your calculator is a skill that I require you to know. Right now, I already showed you how to compute that earlier without inputting the data, right? Okay. I strongly recommend you to learn this though, but eventually on the last day of class or last week of class, basically, you will need to know how to do this too when we do what we call linear regression. 4.77 is the fifth data. The sixth data, 4.77 also. 5.72 is the seventh data. 4.75 is the eighth data. 5.02 is the ninth data. 4.74 is the 10th data. 4.76 is the 11th data. 4.56 is the 12th data. So now I already input all 12 data. Now, once you input the data, let's say in L1, into L1. Then to compute, you will go to Stat, Calculate, one for stats. Okay, you go to Stat, Calculate, one for stats, like what we see here. Now then, which list you are working on? List 1, right? List 1, that's second L1. The frequency list, you can leave it empty, or if it is not empty, use 1. But not 0, not 0, okay? I'll just enter it and then calculate, and it will give me the summary right away. Let me screenshot that. Let me put it here for comparison. Okay, you see that the sample mean is what we have, right? Sample standard deviation is what we have, but ours is rounded to 5 decimal places. Okay, in fact, it helps us to compute fast the sum of x, right? The sum of x and the sum of x squared. You see that? So what we do here is valuable to find not only the sum of x and sum of x squared, but also to help us confirming if our computation for x bar and sample standard deviation is correct. Okay, there were even times I said in my test, use your calculator feature to find sample mean and sample standard deviation. If that's the case, you basically do, using your calculator, do this. Okay, one var stats, and then you, the list, you use L1. The frequency list, either you set it empty or input 1. Okay, that's how we do it. That's how we do it. Now, let me ask you to do some exercise on, let's say number 35. Let me see. No. Number 46. Let's do number 46. Let's just take a look on the data set. Number 46. The data set is that. Let me enlarge that a little bit. And what I want you to do is to find the n is easy, the n is 12, but I need you to find the sum of x and the sum of x squared, and then the sample mean and sample standard deviation using your calculator. So I need you to go back, maybe you input that in second list, right? So you go ahead to input data right away, but put it in second list. Okay, now after you input the data, I want you to tell me what you get by calculating the one variable stats. If you input the data in L2, the second list, then of course you ask the calculator to compute one var stats of L2 instead of L1. Okay, the frequency list, either you set it empty or input 1. If I were you, I would just leave it empty. Okay, let me ask you to do this. I give you 1 to 3 minutes from now. That will be 5:36. I'm sorry, I forgot to record it. I totally forgot to record it. So number 46, I used that. How do we use calculator to confirm our confidence interval from data set? What you do is you use this. Okay, in my example that I didn't show here, I will show that again. Is how to get this t interval here. Okay, how to get that in t interval. Now we put this data into list number 1. Right, we put that data into list number 1. Let me show you how to do that. You go to stats, go to tests, and then t interval. Now, instead you use what we did before. We put in the stats, right? Where then you will input the sample mean, sample standard deviation, sample size, and confidence level. Now, instead, now you choose the data. That means you have the raw data. Now, the raw data will be from list 1. The frequency list or the frequency always use 1. Confidence level 95%. Calculate. Okay, that's how we get. Where's that? This one here. That's how we get this. Yeah, that's how we get this one here. You see that? Okay, that's how we get this one. Okay, and then after that, after this, I show how to compute minimum sample size. Okay, minimum sample size consists of 2 steps instead of only 1 step. Our textbook only show 1 step. Our textbook only use 1 step. No, actually, no, you're supposed to do the second step maybe twice. So from the first step, you will get the minimum sample size, but that's because you assume standard normal distribution. What you will do in your second step is you use that n from step 1, but you find the critical value in t distribution instead. You plug into the same formula actually, but this time you change the position, right? Okay, you change the critical value from C score becomes T score. Once you get the N, you update your T score again. Now, usually you just need to repeat step 2 one time, like in my example here, that you get the same number. Once you get the same number in step 2, you can stop. But I once have a case back at USC. I once have a case where I need to repeat step 2 3 times. So let's say first I get 69, and then when I use that 69, I get 68, and then after that I get 68 again. Now, once you get the same number twice after repeating step 2 twice, then you know that's where you can stop. Okay. Now, suggested homework from here. Please refer to the notes, okay, to go slower. But suggested homework from here. So here I show what's wrong with our textbook formula. Our textbook just do it. Our textbook basically just do step 1. Our textbook just do step 1, but that's not correct. That's not correct. You need to update using T critical. Plug into the same formula again until you get the same number N twice. Okay. The suggested homework from 9.2 will be from here. Yeah, please practice though. On Wednesday, I plan to go over all tests. Okay, but my all tests will include normal distribution, central limit theorem, okay, confidence interval for mu with sigma known. That's what we learned last Wednesday. Okay, minimum sample size. And then confidence interval for P, which I'm about to do right now, but I need to get later a little break. But even confidence interval for P, later on you will see, depends heavily on the template we learn, the one that is not in our textbook. Here's the template. Let me write it down again. Confidence interval for mu with sigma known. Step 1, best point estimate. The best point estimate mu hat is X bar. Critical value, we use C critical. Okay, and then Margin of error is C critical times sigma over square root of n. And then step 3, declaration, confidence interval for mu, best point estimate minus margin of error less than mu, less than best point estimate plus margin of error. That's the template we have before. Now, what happens if we want to do confidence interval for population proportion? Where will that change? It will change in the first step. The best point estimate for population proportion is sample proportion, number of successes over n. Okay, now, then the second change will be in the margin of error. Margin of error will be the same critical value times, instead of using sigma, so the change here, this is the change, another change with the sigma, which is square root of p hat q hat over square root of n, which we usually say the margin of error equals to the critical value times the square root of p hat q hat over n. Now then what happened with the confidence interval then? It will be confidence, you know what, let me use black color for the one doesn't change. Okay, let me use black color for the one doesn't change. Best point estimate, margin of error equals to critical value. So the one change, I write it in blue. Okay, so in step 3, confidence interval for population proportion P later on will be P hat minus margin of error we get in part 2, step 2, less than P less than best point estimate plus margin of error. Again, the blue part is the one changes. Let me emphasize that with the coloring. Okay, I will take a break and then, oh, just in case you want to know, what is Q hat? Q hat is 1 minus P hat. Okay, I will take a break. I will come back at 6:25 and then we will do some problems from there. And then I need to say something about 9.3. See you later. I forgot to, okay, I forgot to record it again. Suppose in example 1, we have sample size 254, and among those 254 people, 112 of them have certain characteristic. Let's say 112 of them actually college students. Now we want to see if what's the population proportion of people of college students in that population. Okay, now then population proportion is the number of college students among the sample. That's what we get. That's the sample proportion. Okay, and then we do the C score, the critical value. It's inverse norm. Area to the left is the confidence level 95% plus half of the remaining of 5%. That's how we get that 97.5%. that will give us critical value 1.95996. Then second step, how about the margin of error? Margin of error will be 1.95996, the critical value, times the square root of p hat 0.44094 times q hat 0.55906 over the sample size 254. Now this 254 is still under square root. Okay, this 254 is still under square root. So if I use my calculator, let me show you how to punch into your calculator. So 1.95996 times the square root of 0.44094 times 0.55906. This is still under square root though. Okay, divided by 254, still under square root. So our margin of error is 0.06106. 0.06106. Now, because this is the margin of error for proportion, we do expect the margin of error should be less than 1. Okay, because this is about proportion, right? Okay, so 95% confidence interval for P will be the best point estimate minus margin of error less than P, not mu, less than best point estimate plus margin of error. Okay, 0.44094 minus 0.06106. That is 0.37 what? 988. So the population proportion will be almost 38% of the population, up to approximately 50% something, 0.50200. Okay, we are 95% confident that the proportion of college students in this population is between approximately 38% to 50.2%. Okay, to confirm using calculator, you will go to stat, test, and then you go to one, I forgot, and I need to look at the calculator. That's stats, test, one proportion, z interval. This one proportion z interval. Okay, that's where you go. One proportion z interval. Then they will ask you how many people or how many elements of that sample has this characteristic, and what is the sample size, and what is the confidence level. It's my calculator. Okay, so if I want to confirm using calculator, this is what I have. Again, confirming using calculator is not to substitute or to replace the technique I show you. Okay. And the rest of this section, besides some others, actually will be very similar. So suggested homework from here will be, I'll give you only one example because it's just applying the formulas. 9.1, I need you to do number, actually you can start working with number 11 to number 19. And then 25 to 29. Okay, now the last topic, minimum sample size, which I will not go over today. Minimum sample size n is equals to the critical value squared times p hat q hat over margin of error squared. With some note, if p hat is unknown, then use p hat equals to 0.5. Now, consequently, q hat will also be 0.5. Okay, so if the p is unknown, p hat is unknown, the formula becomes n equals to square root ceiling of c critical squared 0.5 times 0.5 over margin of error squared. This Wednesday, we will do more problems from my old tests, especially. Okay, from my old tests. And of course, I will do 9.3 also this Wednesday. I will do 9.3 this Wednesday. I can give you the formula, but what I want to do, what I really need to do is this 9.3. That's confidence interval for population standard deviation for population variance. Okay, the template is different from others. The template is different from others. Step 1, we will look for chi-squared right. And step 2, we will look for chi-squared left. Step 3, then declaration. And the formula will be n minus 1 s squared over chi-squared right less than sigma squared less than n minus 1 s squared over chi-squared left. That's the template. Now the thing is, we need to use calculator to get this. Now the worst part is, it is actually not in our calculator. Okay, we need to program this first. We need to program this. Okay, now see the link on our discussion board for today. The one on the 26th. Let me put the link on our board then. I have to finish chapter 9 today. I cannot because we basically did 9.2 and 9.1. To prepare for 9.3, please program your calculator. You have to program this. Even if you have the online calculator, the emulator, okay, you need to program your calculator to find inverse chi. Please watch the following YouTube video to program it. Where is that YouTube video? You go to YouTube. And then we will do inverse chi squared for TI-84 program. We will use this one. Not this advertisement though. Oh, I'm sorry, not this one. I don't think it's this one. Should be this one then. No. Why I don't see that anymore? I recognize the author, but it's not those two though. Should be this one. That's right. But why did that person changes? It's not supposed to be that one. Give me a second. Why it changes? I think she actually changed the name here, but it's supposed to be something else. So it should be this one. Okay, I will share, copy the link, and put it into our discussion. Okay, if you can't program it yourself, then please come to my office hour on Wednesday, which is April the 28th. Okay, my office hour starts at 3 o'clock. But I strongly suggest you to just use this video here. The good thing with this video is you can stop the video and you can repeat it. Okay, you can ask like this guy here, if you, in this case here. So the good thing is if you kind of lost with what she did, you can repeat it, right? You can stop like what I'm doing right now, and then you can repeat it. You see what I mean? Oh. Yeah, it would be much better if you actually spend time together with her using that lecture video to program that. Okay, now here's the thing though. What I plan to do on Wednesday, we plan to finish 9.3 and then go over one old test 3. Okay, now if we have time, if we have more time, we will do more old test 3. What do you think? But here's what usually happen. This is what usually happen. You don't do what I ask you to do. So you come on Wednesday not prepared. So you have no way to do 9.3 because you don't program your calculator yet. What we will do if you don't program it yet? Then we have to spend some time to program that, right? Okay, but if we spend time to program that, we will have less time to actually do 9.3 because you don't do what you're supposed to do at home, right? And less time to do all test 3. So basically it becomes domino effect. Okay, no, that's why I strongly suggest you to program your calculator for that. Okay, please do so. And so on Wednesday, what we will do on Wednesday, we will learn to you already programmed that. Okay, I assume on Wednesday 4 o'clock we already programmed that. So if you have not programmed that by 4 o'clock, right? Let's say you watch the video, you don't know what to do. Okay, you really lost. Then I want you to come at 3 o'clock, let's say 3:30. Okay, give ourselves at least half an hour to program. If you cannot understand what the video is doing, then it will not take you only 10 minutes to understand what I do. If you don't want to spend much time with her, then you may need to spend more time with me. Now, but if you come at 4 o'clock, what do I do? Then I will spend some time. I will just spend my time with you. If you don't do what you're supposed to do, I will just spend my time with you, do the programming at 4 o'clock, which I don't think you want to happen. But we will have less and less time to go over all tests. I want you to realize, when is your test 3? Your test 3 is next Wednesday, May the 5th. So 9 days from now is your test 3. It's really fast. Okay, your test 3 is May the 5th. What I want to do is this, though. What I want to do is the chapters for test 3, basically anything after test 2. So the material topics will be from, let me see the book. From chapters, is it chapter 6 or chapter 7? Oh, chapter 7. Yeah, chapter 7. From chapter 7. That's 7.1 and 7.2 only, as I remember, and then 8.1, and then 9.1 to 9.3, and Bayes' theorem. Okay, chapter 7, 7.1, 7.2, and then 8.1, 9.1 to 9.3, and then Bayes' theorem. Now, what I want to happen is you already program your calculator such that on Wednesday, when we come back, we only do this, like we can do it really fast using calculator, and then we do this, applying, it's just applying formulas. Okay, it's just applying formula. We're supposed to be able to finish this material 9.3 here within like around 45 minutes so that we have more time to do previous tests. Okay. Oh, you may say, Thomas, test 3 is May the 5th. So we actually have 2 days to do review, right? No. You are thinking that May the 3rd, Monday next week, you want to do review. But I don't want to. I don't want to spend 2 days to do review. I only do 1 day. Okay, it's better for me to do it this Wednesday so that this weekend you have a guide how to study. Okay. Why don't you spend 2 days, Thomas? Because we still have material for test 4 that we need to catch. Come on, if you don't do what you're supposed to do at home, why do we need to do it during our class time? Okay, do what you need to do at home. Okay, so that we can spend reasonable time to go over all tests. And we don't, we should not do review, but you don't study at home. No, you should, okay? Remember that we have that issue on the first test, and I knew it will happen, that your test 1, because you are not prepared for your test 1, your test 2 was not as good. Only one person did well. Only one person did well. Okay, that person got 84. While my ELEC class, I have 2 students score more than 100. You know, in fact, one person get only half point off. Out of 105 perfect point, that person get 104, 104.5. Okay, so please do your part. Please do your part. Okay, I will just leave it off here for 9.3. That is what I will continue on Wednesday. Okay, on Wednesday, we will do 9.3 and then go on with all tests. Okay, let me post the all tests I will go over on this Wednesday also. Which semester you want me to go over? Any idea?
Last semester.
Which was fall 20?
Yeah.
Fall 20? Yeah, okay, fall 20. So this is the all tests we will go over. All tests we will go over. That will be from fall 20. Let me put the data, the file in.
Or even spring 20, maybe.
We can do only one.
Oh, okay.
Yeah, we can do only one. I mean, I can do more. I can do more, but given the time we have, the answer is no. Right? Okay, because we cannot just go over tests without foundation. And then when I do foundation, when we go over tests, you will end up asking me a question, how do you get this? How do you get that? Fall 20 consists of 2 parts. That's the in-class and then the supplement. But for you, you will not get supplement.
Professor, maybe it'd be very helpful for us if we just posted the test and the solution if we don't have time to go over all over the spring and fall, whatever. We just have to look at the post you already submitted. I mean, it would be very helpful anyway, you know.
I know, but it will be very helpful also if you know that I already posted on my website.
Oh, okay.
So is it helpful if you actually know that?
Okay.
It's like you asked me to do what is helpful, which I already done.
Yeah.
Right? So who is the one not helping yourself? I'm sorry, I'm a bit not happy because what? Because I already did my part. And you don't do your part. Oh. Yeah. If we have time on Wednesday, then yes, we can do spring 20. Let me post it here too. if we have time.
Yeah.
Right, but let me post the tests here, the blank test. Oops. Two 27 elect test 3. So let me give you these two sets here, and then you figure out on this Thursday which one you want me to go over. Okay. Now the good thing with my Friday class is they almost finished the material. They are only missing that 9.3 part. Okay, and then after they're done on Friday with that 9.3, the material for their for their confidence interval for population variance, then I can go over all tests with them, and very likely I can go over 2 different tests with them. That's because they actually did their part, right? With you, well, basically this though. Please do yourself a favor. Okay, program your calculator. Because otherwise, no, you have so less things to actually study from. Okay, it's not that I don't want to help you. You like what I said. What you want me to do, I already done even before you do that. You asked me to do that, right? Okay, the solution is on my website. You can see it there. Okay, but then what usually happen is, even if I put it there, you don't even know it's there. So what's the point of me putting it there? Well, anyway, this is where I will stop. Then see you on Wednesday. Make sure you program that for me. Okay.